3. Formation of X-ray images. So you know that the attenuation of X-rays depends on the nature of tissue and its thickness. So when a fan of X-ray is projected through a body, it will have different transmitted intensities, which create different shades of gray on a photographic film placed on the other side. This is called X-ray planar imaging, or simply X-ray imaging. A. Attenuation of tissues. When X-rays pass through different body tissues, the transmitted intensities change with the density of tissue and the thickness of tissue. When a uniform beam of X-rays pass through a body, the rays that try to pass through the bones are highly attenuated, and so the transmitted X-ray becomes very weak. On the other hand, for the rays that pass through the air-filled lungs, they are least attenuated, and so the transmitted X-ray would be quite strong, which will then produce a stronger blackening of the film. Note also that we are detecting the transmitted X-ray, while for ultrasound imaging, the transducer detects the reflected ultrasound, but not the transmitted one. B. X-ray film exposure. Photographic film is often used as a detector for X-rays, as it is cheap and handy. The transmitted X-ray exposes the film. The area behind the lungs are exposed and hence blackened. The areas behind the bones are, on the other hand, least exposed, and so eventually appear white. In other words, an X-ray image is a map of attenuation of X-ray beams after passing through the body tissue. So, just remember that the area with more attenuation appears brighter in the film. 4. Interpreting X-ray images for medical use. From an X-ray image, we may identify different types of body tissues by comparing different shades of gray. In general, black areas suggest gas. Gray areas suggest soft tissues. White areas suggest bones or metals. A higher contrast X-ray image allows you to identify separate structures, such as bone and flesh. Heart and liver have similar attenuation, and so they are more difficult to identify. X-ray imaging is cheap, fast, and widely available, and that's why it is widely used in the following cases. Case 1. Bone fracture. We can easily identify bone fracture from an X-ray image. Case 2. Lung infection. We can see from this X-ray image that when there is lung infection, this area will appear white. Why? When there is infection, there will be pus. So that infected parts would have a lot of fluid, and so the attenuation of X-rays becomes much higher, and eventually produce a white area in the X-ray film. For other lung diseases such as tuberculosis, TB, chest examination using X-ray image is still popular, as it is quick and cheap and easily available. And most importantly, the infection of the lung can be easily identified from X-ray images. 5. Artificial contrast media. For soft tissues, the attenuation are similar, and so the contrast between the structures is low. To increase the contrast and highlight an organ of interest, artificial contrast medium, ACM, is used. Barium and iodine are common artificial contrast medium, as they are non-toxic and they don't produce any adverse reaction. They have high linear attenuation coefficient, and yet they can be excreted from the body soon afterwards. Barium is usually swallowed directly and be used as contrast medium for digestive system such as stomach and intestines. Iodine, on the other hand, is injected directly into the bloodstream for X-ray imaging of the circulatory systems such as heart and blood vessels. With the artificial contrast medium, the attenuation of X-rays is greatly increased, and the target organs will appear white on the film as the transmitted intensity falls drastically. When abnormality is identified, endoscopic diagnosis such as biopsy often follows, so that the suspicious tissue may be sampled. Exam link 1. X-ray traveling in different media. This question is straightforward. Don't be scared by the unfamiliar X-ray image. Parts A and B are unrelated, however. Read the solution carefully. Lastly, let's talk about the advantages and disadvantages of X-ray imaging. A. Advantages. As mentioned above, X-ray imaging is still popular because it is cheap, fast, and easily available. That make it the best solution to identify broken bones and lung diseases. And it is also important for screening lung diseases in a large population, including TB, SARS, and avian influenza, especially in epidemic situations. B. Disadvantages. X-ray images is a 2D image. Overlapping body structures creates unclear images and hence uncertainty for tissue examination. X-ray is an ionizing radiation which may attack cell nucleus. Prolonged or excess exposure can easily cause cancer. Also, unless we use artificial contrast medium, the contrast between soft tissues is limited, and so they are not easily distinguished in the X-ray film without ACM. And X-ray images are static images, which is a single snapshot. Unlike endoscope, X-rays images do not provide real-time video for examination, and tissue sampling is not allowed there. Nevertheless, X-ray imaging is still often used as a screening tool. Lastly, there's still a small chance of allergic reaction due to the artificial contrast medium. Now, do check point 2 on the next page.